Okay, class, in this lesson we're going to learn how to test for symmetry. And what symmetry is if I had a graph like a parabola, like this one, we want to know where it's symmetric. In other words, where could I draw a line that if I cut it in half, I could fold it on that line and both sides would be equivalent. The left side would be equal to the right side. In other words, they would line up when I fold it. Well, a parabola, usually, or if it's on the origin like this one, would be symmetric on the y-axis. Okay, but it wouldn't be symmetric if I drew a line here and folded it. It would end up down here, and there's nothing down there, so it's not symmetric there. And then symmetric to the origin means I could fold it diagonally like this. Okay, and I probably have too many lines there, but I could fold it diagonally like this, and it would not, for this particular graph, would not be symmetric. An example of something that would be symmetric across the origin would be if I drew a circle. Okay, if I drew a circle, okay, I could fold it here, I could fold it here, and it's symmetric any way you fold it. It'll all line up. Okay, so we've got a couple tests here that we're supposed to run on each one of these problems to see if they're symmetric without actually having to graph them. So this is a parabola, but we don't have to graph it. We just have to figure out what it's symmetric to, and we do that by plugging in to a negative x in for x. Okay, so if I plug a negative x in for x, what I'm looking for is that the equation will not change. So no change. Okay, so right here, plug in a negative. If I put in a negative x in for x and squared it, well, what would happen if you square something? It turns positive. So this would turn back into x squared plus 4. So because there was no change to my equation, this one checks off as having symmetry to the y-axis. And that's just like the one that basically what's happening here is 1, 2, 3, 4. We have a parabola like that. And of course you could fold it on the y-axis and it's symmetric. Okay? Well, now let's do the check for the x-axis. We already know what's going to happen. It doesn't have symmetry there because it wouldn't fold and touch something. But what you're supposed to do is plug in a negative y value to see if you have symmetry for the x-axis. So over here I put a negative in for y. In other words, I put a negative y where the y is. And then the question is does it change the formula? Well, yes, it does, because it doesn't clear itself out like the x did. So because that did change, so this is not symmetric to the x-axis. Okay? And now finally, what you're supposed to do, one more test, is symmetry for the origin. And to do that, you need to plug in a negative x and a negative y at the same time to see if they happen to cancel out that way. Well, if I put a negative x in here, this negative goes away. This one's still here, so it still changed the formula from the original formula, and so it is not symmetric to the origin. Okay? And again, we can see that up in the picture. I can't fold it this way and have it line up. Okay? So now we're going to try this other one. It's y squared minus x minus 2. Technically, this is the formula for a circle, so just throwing that out there, just a little background knowledge. But what I do is I plug in symmetric for the y-axis. I plug in a negative x. So if I put a negative here and then it got squared, well, that would turn back into what I had, y squared minus x squared equals 2. So no change there. Okay. Well, that means it is symmetric to the y-axis. And then we're going to check it for symmetry for the x-axis. So I put in a negative in for the y. It squares itself, so I'm back down to y squared minus x squared. So no change again, that's perfect. So symmetric for the x-axis. And now you do it both at the same time. So negative for y, negative for x, they both canceled, so that means I have symmetry about the origin. So that's exactly how you work through these problems to test for symmetry. Okay. So let's test for symmetry on this problem. So to test for the x-axis, I plug in a y, so x-axis check. I plug in a negative here. So this is absolute value of x plus negative y equals 4. So the question is, did I change the formula? Yes, I changed the formula because that doesn't cancel out. So it is not symmetric to the x-axis. So I put no. Okay. So now let's check for symmetry on the y-axis. So to check for the y-axis, what I'm supposed to do is plug in a negative in for the x value. Well, if I have an absolute value of a negative x, that's going to turn into a positive x. Because if you take the absolute value of something, it makes it positive. So I'm back to x, absolute value of x plus y equals 4. So yes, it checks out. It has symmetry on the y-axis. So our last and final test is that I check for the origin. So now I plug in a negative here and also a negative y. Well, that'll cause me to end up with a negative y. And so I did change the formula. If the formula changes, it is not symmetric around the origin. Okay, so this one is only symmetric about the y-axis. And it's possible that you have some problems where it's not symmetric at all. So you write no. Or, well, it's not symmetric for the x, y, and the origin. It could be symmetric on a different number, but we're not looking for that.